In this lesson, you will use the engine balancing function in the ONS to balance the N1 fan after maintenance. Perform a vibration survey of the engine. Find the existing balance weights data. Use the ONS to calculate the new balance weights and the weight locations. Install new weights on the engine, and return the airplane to service. The left engine has just had a set of fan blades replaced. Your task is to perform the balance survey and check the configuration of the engine. Perform the trim balance procedure, change the trim balance weights, and return the airplane to service. You will use a portable maintenance device to connect the airplane's ONS. All balance operations will be performed on the maintenance laptop. To begin, find the appropriate procedure in the maintenance manual. The fan blade set was replaced. You must do test number 9 in the AMM. Always follow the steps in the AMM. Proceed. Good, you have found the test procedure. Now proceed past the general information to the first steps. Good, your first step is to provide power to the EEC. Now supply power to the left engine EEC. To supply power to the left EEC, you must first go into the maintenance control pages. Good. Now go to the miscellaneous system control page. Good. Now set the left engine EEC maintenance power soft switch on the miscellaneous system controls page on the MFD to the test position. The next step is to set the ground test switch to the enable position. Good. Now set the ground test switch on the P61 panel to the enable position. Good. The engine EECs are now ready to communicate with the aircraft ONS. Next, you will connect the maintenance laptop to the airplane's ONS port. Find the ONS port. Your check of the vibration data shows that you must balance the left engine. Now connect your maintenance device to the airplane's ONS port. Good. Now continue with the maintenance procedure. Your next step will be to start the maintenance laptop and go to the engine health management function. Good. Now start the maintenance laptop and connect to the ONS. These are the onboard network system menu items. Begin by going to the Other Functions menu. Good. Now select the EHM function. Once EHM is selected, you will enter the engine balance function. Follow all maintenance manual procedures during this step. Continue. The AMM procedures tells you to select the engine and confirm that the balance weights are correct. The maintenance was performed on the left engine. Select the left engine and continue. Good. Notice the engine turns green when it is selected and all conditions are met. If the conditions are not met for this function, the engine color would be yellow. There are no weights listed in the fan weight configuration. Now go check to see that this matches with what is installed on the engine. Now go to the left engine and locate the fan trim balance weights. Be sure to follow all safety precautions and procedures in the AMM. Where are the balance weights located on the LEAP motor? Good. You must remove the spinner to access the fan balance weights. The spinner is held in place by 9 Torx Plus type fasteners. With the spinner removed, we can see the platform front shroud. If weights are installed, they will be installed here. There are no weights installed on this engine. Good. Now put the aerodynamic spinner back on. Before you continue, you must first set the stability criteria. You do this on the EHM menu. Now set the data criteria. Choose the Functions drop-down menu. Select the Data Criteria function to continue. For this exercise, we will use the Medium Data Criteria. Select the Medium Data Criteria. You will now prepare the EHM function to record the vibration during the ground run. Select the Ground Run function to continue. Select Record to begin recording the vibration. Vibration level will be recorded for each of the ground run speed target bins. Slowly increase the thrust lever to record the vibration. Good. You have recorded data in each of the speed bins. Now you can return the thrust lever to idle and save your data. Follow the instructions in the AMM. Good. You have filled the ground run speed bins with vibration data. Now save the vibration data from your ground run. Good. Your data has been saved. Select OK to continue. Now you can shut the engine down. If the engine shows low vibration, then you are finished. If the engine shows high vibration, then proceed to test number 11. When the vibration level is not acceptable, it displays in amber. You must do the trim balance procedure. The trim balance procedure is in test 11. Always follow the steps in the AMM. Now go to section H of test number 11. You have already checked the balance weights, so move to step 2. Select Trim Balance. The ground run data collection has already been accomplished. Continue with the engine balance using the ground run data you have recorded. Select the ground run leg and continue with the trim balance procedure. The generic coefficients are set by default. For this exercise, we will use the generic coefficients. Continue. Good. Now use the maintenance laptop to calculate a new balance solution. Find the solution for the new engine trim balance configuration. For this exercise, we will perform the one-plane solution. The predicted vibration reduction is 42%. This will be acceptable. Accept the weight change. Now accept the solution one more time to continue. Now continue with the procedure. Next, you need to print the new trim balance weight report and go add the new weights to the engine. You must export the weight report to print it. And send the report to the File Download Manager. You must go to the Home menu to find the weight report. Now go to the Download Manager and find the report you just generated. The EHM Report tab is where the report you just generated is stored. Select the EHM report. Good. Now you can view the files in the EHM report. The report you just generated has not been transferred yet. Transfer the new report to your computer. Now open the EHM report you just transferred. These are the weights that need to be changed. Now go to the engine and finish the job. Identify the area on the engine where the fan trim balance weights are located. Good. You must remove the spinner to access the fan balance weights. Next, you need to locate the holes where the fan trim balance weights will be installed. With the spinner removed, we can see the platform front shroud. If weights are installed, they will be installed here. There are no weights installed on this engine. Now install the weights that are listed on the report. The weight hole locations are identified on the engine. Now locate the holes that will have weights installed. Locate the holes where P02 weights will be added. Locate the holes where P03 weights will be added. Good. The balance weights have been added. You have installed the weights in the correct weight holes. Now, reinstall the spinner on the engine. Good. You have changed the fan trim balance weights on the engine. Now return the airplane back to its usual condition. Always follow the steps in the AVM. In this lesson, you use the engine balancing function in the ONS to reduce the N1 vibration of an engine, found the vibration history of the engine, found the existing balance weights data, used the ONS to calculate the new balance weights and the weight locations, installed the new weights on the engine, and returned the airplane to service.